This video describes a conceptual model for small, repeatable heat networks. Developed on behalf of Liverpool City Council, this work was funded by Innovate UK, a part of UKRI. What is a heat network? Heat networks have existed in the UK since the 1970s, although their adoption has been relatively limited, in part due to needing a high density of consumers. Generally, they have used large-scale fossil fuel boilers as the heat source, although some are now converting to lower carbon technologies, such as heat pumps. Heat is generated at an energy centre, then distributed to consumers in the form of hot water through a network of highly insulated pipes. The heat is transferred, using special equipment within the property, to serve the consumer's own heating system and hot water outlets. This process results in cooling of the network water, which is returned back to the energy centre for reheating. The conceptual model, an introduction. As the name implies, our conceptual model for small, repeatable heat networks takes a different approach than large-scale heat networks. Our heat networks would start at a local level, using small energy centres that utilise low-carbon technologies such as heat pumps. They would be supported by an ambient loop, which can expand over time, using waste heat and naturally occurring heat to increase the water temperature used by each energy centre. There are several key benefits to this approach, including efficiency through repetition. Networks can grow over time. The approach would be applicable to many areas, not just large cities. The ambient loop would unlock low-carbon energy potential in the UK. Maximising heat storage and reuse. It would reduce peak energy demand on the electricity network, reduce cost and investment risk, and it would support local supply chains and create jobs. The conceptual model overview. The conceptual model consists of the following 4 components. 1. The ambient loop, including heat sources. 2. Local energy centres. 3. Local networks. 4. Customer connections. What is an ambient loop and how is it used? An ambient loop is a buried pipe network that carries lower temperature water, warmed by natural or waste heat, to heat pumps, which can upgrade this heat to central heating and domestic hot water temperatures. In the conceptual model, the ambient loop is used to transport heat from naturally occurring heat sources, such as geothermal energy, and waste heat sources, such as data centres. This heat, which is already at 40 degrees Celsius, is delivered to the local energy centre's heat pumps, which boost this water temperature to 70 degrees Celsius, with an efficiency of over 450%. The ambient loop may serve more than 20 local energy centres. How does the energy centre work? The energy centre has a number of key components. Low-carbon water source heat pumps, providing roughly 95% of the heat, using the ambient loop as a heat source. Gas boilers, which provide around 5% of overall heat, supporting peak demand requirements and available to provide full 100% heating system backup. Thermal stores, which act like a thermos flask, to reduce heat loss in stored water and help balance demand. In addition, there is various ancillary equipment, such as pipework, valves, electrical equipment, and backup systems. Energy centres will be small in scale, rather than large industrial complexes, so they can work at a neighbourhood level, without needing a large physical footprint. By taking in pre-warmed water from the ambient loop, already at 40 degrees Celsius, and by using primarily heat pump technology powered by low-carbon electricity, the energy centre is a highly efficient, low-carbon method to deliver heat energy at a local level. The local network. A network of highly insulated buried pipes distribute the 70 degrees Celsius water from the energy centre to each customer's property. Each local network is expected to serve 800 to 1,400 customers, depending on the mix of customer types. This pipework delivers hot water and returns used, cooler water back to the energy centre for reheating. What happens in a property? Each connected property will contain equipment similar in size to a gas boiler, called a heat interface unit. The heat interface unit transfers heat from the network to the building's own heating systems and hot water outlets. The building's water and heating system is isolated from the heat network, meaning that the distributed water is not physically used, only its heat energy is transferred to the property. The heat interface unit also incorporates a meter to measure heat use, so that customers can be billed for the heat they use. Heat interface units have the advantage of being a direct replacement for existing combi boilers, as their size and 70 degrees Celsius output temperature match the required characteristics. This means that heat outputs are similar to traditional boilers, meaning there is no need for additional building insulation and can use existing radiator systems. What makes this low carbon? There are many sources of ambient heat which could potentially be utilized to supply warm water to the energy center. One example is our sewerage systems, which contain waste heat from hot water used in homes, which can be transmitted to the ambient loop through heat transfer technology. Another example is waste heat generated by data centers, which can be captured. A main contributor to the ambient loop is expected to be geothermal energy, which is widely available, low carbon, and can achieve higher temperatures than other forms of natural heat. Sources can be added to the heat network's ambient loop as it expands, spreading capital investment over time. By making better use of naturally occurring or waste heat, the ambient loop can significantly improve efficiency, electricity use, and carbon emissions. A repeatable approach to expansion. The local energy centres will all follow the same core design, so that economies of scale can be achieved, with a high cut-and-paste approach to their design and build. This approach reduces both cost and time during construction, and improves operation and maintenance through common equipment and replacement parts. Each local energy centre can gradually develop in line with demand for customer connections, with the local network growing until it reaches its limit of between 800 and 1,400 customers. The other local energy centres can develop separately to provide heat to adjacent areas, with the ambient loop growing to supply each new local energy centre. This repetition allows groups of local networks to combine and operate at a town scale. Multiple town-scale networks can then develop, ultimately allowing the small, repeatable heat networks to provide low-carbon heating and hot water at a city-wide scale. Further information available. Further work relating to the conceptual model includes a detailed report on the concept of small, repeatable heat networks, a hypothetical study into the application of the concept in the Newsham Park area of Liverpool, and a Liverpool-scale conceptual model master plan. For more information, please contact any member of the project team.